Okay, good morning, good afternoon, and good evening, depending on who and when you're watching. Okay, so I'm gonna be working with my fourth period class. I'll be recording my fourth period. So fourth period. Remember today's journals. You will be writing three goals you have set for yourself as far as journals go. It could be long term, maybe what you see yourself in the future, or it could be just for this 2020 year. Okay, so we will be talking about three topics: physical properties, extensive and intensive properties. It's going to be much easier than what we did on Thursday and Friday. I know Thursday and Friday was a lot. There was a lot of math, a lot of all that, new stuff, new topics, new content that you might have not, might have had trouble with. Remember, if you did have trouble with Thursday and Friday, I've already uploaded a video of my lecture so you guys can watch it again more slowly. Okay. We're going to be doing some reading. We're going to be discussing. We're going to be talking about a lot of examples. And these examples, guys, I'm telling you right now, make sure you write them down or you have them highlighted because they will come up in your review questions. We're going to be watching videos and discussing videos. And then obviously you'll be doing some independent practice. And you should have time to finish both sections before you leave today. So be ready to upload right after we're done presenting, okay? So let's jump into it. We're on week 3. Remember, grades are due on Friday as far as your progress report goes. So make sure you get me whatever you have from the last 3 weeks. Turn in something. If not, your grades are going to look bad. Okay. If you got a bunch of zeros and some 80s and 90s, it'll balance out to a really bad grade, about a 50. But if you have 80s and 90s with 50s because you've turned in something for every day, your grades will be a lot better. So today we're going to start with 2.3. I believe this is on packet page 38. Here you have an example of a stock car. These stock cars do drag racing. Basically, it's a head to head race to see who can get to the finish line faster. Okay, the drag racing is very highly competitive. It's an expensive sport. There are a lot of different types of classes of vehicles. You have some stock classes, some stock car classes. There are also some classes dependent on the car weight, the engine size, the types of modifications you've done to your engine, all the way to what they call top fuel classes. Okay, and weights for these cars can be over 2,000 pounds and they could reach top speeds of over 300 miles per hour. Both of these topics right now, both of these characteristics are physical characteristics of what these cars can do. So our first topic is known as as physical properties. I like to think as physical properties being like features of our substances. Like I have facial features, I have really small eyes, some people have really big eyes. I have dark hair, some people have light or brown hair or even blonde hair or even red hair, especially, and then my complexion, it's not really like a pale complexion, but I'm not really tan too. So those are all different physical features of myself. Now, when it comes to substances and elements, they can also have physical properties. We call them physical properties. Instead of saying physical features like we do for people, well, for substances, we say physical properties, okay? And these are characteristics that can be observed with, you can see them or you can measure them in a certain way, okay? And all of these features, they do not change the substance that you are working with, okay? And the first example they give us is silver, okay? Here's an example of, silver. Maybe this is not actual silver. It could be titanium. It could be, any type of metal because, we don't really know. A lot of our iPhones, They have a lot of different. They're made of a lot of different types of substances, a lot of different types of metal. But one thing we know about this metal in particular is that it's shiny. You know, you can see it reflecting the light that's coming from the window. It's probably also capable of conducting electricity. If I wanted to, I could probably, with enough force, bend the metal that makes this cell phone. Anytime that you can bend metal into thin sheets, in this case, you call that, it's now going to be known as malleability. Okay. All it is just taking a chunk of metal and flattening it out. Okay. Salt, everybody has seen salt at home. It's dull, meaning it's not shiny. It's brittle, meaning it could be broken down further. It does have the ability to conduct electricity, but not when it's a solid, when it has been dissolved, excuse me, into water. Okay. Physical properties of matter include, here's a bunch of examples of physical properties. You have color, okay? Hardness, you know how hard something is. Not all substances are hard. Some you have very soft and brittle um, substances. Like example, we're talking about the salt being very, very brittle. Malleability, again, we said that's the ability to, and I'm sorry if I'm looking at my phone, the ability to bend into thin sheets, metals. Solubility is just dissolving, and usually it's in water. If we say solubility, it's usually we're talking about dissolving substances in water. Electroconductivity, that just means electricity can pass through it. Density, we studied that last week. That's mass, it's a ratio of mass and volume. Melting point, that speaks for itself when it starts to melt. And boiling point is when the substance begins to boil. Okay. For elements, most elements are colorless, silver, or gray. But there are still some elements that do have color. And for example, here we're talking about chlorine and sulfur, which happen to be yellow. Copper, well, of course, it's copper colored, meaning it looks like kind of bronzy kind of color. And then bromine is red. Okay, so that's some examples of most elements are colorless, silver, or gray. But here are some examples of elements that do have color. Density, we talked about last week. It's used to identify an element of materials that exist at solids in room temperature. Iodine, for example, has a very low density compared to zinc, chromium, and tin. Okay, and that's mostly because iodine is a non-metal, and then zinc, chromium, and tin are metals. Okay, so it has a very, very different type of density. Okay. Gold is one of those that is very, very dense. It's very, very heavy. So I don't know if you've ever seen in the movies people like, oh, here's a gold brick, and they just like throw it at somebody else. Well, more than likely that's a fake gold brick, because gold bricks are extremely heavy. You know, it's very hard to pick up a brick, much less throw it to somebody. Okay. And also platinum is another one that's really, really heavy and really, really dense. Here's some examples of hardness. Hardness can be very, very different for different types of substances. If you want some examples of some elements that are really, really soft, you can talk in terms of gold and silver. Okay, gold and silver comes in a variety of ways. You see gold in earrings, you see gold in necklaces, you see gold on bracelets, you see gold on rings, right? Every girl wants a gold ring with a big diamond. All right. So while others are really, really hard, for example, titanium, tungsten, and chromium are on the other side of the spectrum, meaning that they are really, really hard compared to silver and gold. All of them are metals, just silver and gold are a lot softer than the others. Carbon is an example that can be easily discussed. For example, the lead that's in our pencils. Okay, if you're using a pencil right now, that little, where what you write with exactly, that is carbon. Okay, and it's very, very soft. But if you look at the diamond on this gold ring, that is also carbon. Okay, but the difference between these two carbons is that diamond, first off, has been highly pressurized, meaning there's been a lot of force put into it. It's been really, really hot, and time. It probably has been pressurized and heated for a very long time, okay? And that's what makes carbon into diamonds. Now, diamonds, compared to if you try and draw on glass, well, the carbon's going to break. But if you try and draw using a diamond on glass, you can easily scratch because diamonds are really, really strong in comparison to what you have in that pencil. Melting points and boiling points are also unique identifiers. It can help us identify the type of liquid or substance, because certain elements boil and melt at certain temperatures. In addition to giving some idea as to the identity of the compound, it's very important information that can be obtained about the purity of a sample or material. Okay. And this video is going to show you a lot of examples of physical properties, and then it's going to go into chemical. Okay. What's important right now is the physical part. So pay close attention to the first minute and a half about it, because that's stuff that you really need to know for today.
Physical properties of matter include melting point, boiling point, color, density, magnetism, crystalline shape, malleability, ductility, luster.
Luster is just a fancy word for shiny, guys. Okay. And then on the ductility, where is the ductility? This one. Basically, what you do is you're taking chunks of metal and making them into thin wire. That's what ductility is about. And I'll type it in the chat so you can add it to your list.
Luster. And refractive index. The physical properties of matter can be observed without any change in the matter's chemical composition. Chemical properties, on the other hand, can be observed only when matter undergoes a chemical change. Here are some examples of chemical properties. Hydrogen peroxide decomposes easily into oxygen gas and water. Iron reacts with oxygen to form iron oxide. Sodium metal reacts with water to give off hydrogen gas. Sodium hydrogen carbonate, baking soda, reacts with acid to give off carbon dioxide gas. Lead nitrate reacts with potassium iodide to form a yellow precipitate of lead iodide. Red phosphorus can undergo combustion in air.
So those are a lot of examples of physical properties, and then they went ahead and they introduced you to chemical. Okay, chemical properties we're going to be talking about later this week. I'm not going to go over this one mostly because it's 8 minutes long, and I don't want to confuse you, and I want to make sure that you have time in class to work on these problems, okay? A physical property is a characteristic of a substance that can be observed or measured without changing the identity of the substance. Physical properties include color, density, hardness, melting point, boiling point, luster, ductility, malleability. There's a lot more examples of physical properties, okay? All right, so hold on right there. Okay, so we're back. We're going to be working now on section 2, 2.4, extensive and intensive properties. Okay, we have here an example of a $20 bill. Now, I bet a lot of you guys are always asking mom and dad, Mom, what can I do in order to, earn $20? Well, one of the things that I know I did when I was young to get $20 out of my dad, I would always say, hey, I'll mow the lawn. You don't have to worry about it. I'll take care of it. The only thing that you have to do is, do the weed eating. I didn't know how to do that. So that would be the only thing that they would have to help me with. But as far as mowing the lawn, I was always able to, wrangle $20 out of him. Now, when he gave me those $20, the only thing I made sure was that there was a 2 and a 0. Why? Because I didn't really care about the actual dollar itself. But if you look at, if you get a new $20 bill, it's nice, it's crisp, it's brand new, it's got a different smell to it, and it's definitely got a different feel to it. And it's got different features. It's got, a watermark. If you hold it up to the light, you can see also the strip where it proves that it's authentic. Different $20 bills have different features, okay? But all of them are worth the same thing eventually, right? If I go to the store and I take an old $20 bill, it's still a $20 bill. Doesn't matter if it's a new one or an old one. So let's talk about extensive and intensive properties, okay? Extensive properties, first off, is I like to always think of it extensive as something that I can measure. If I can measure something out of a substance, mass, volume, length, width, height, all of those are going to be known as extensive property. Why? Because an extensive property is a property that depends on how much matter is in that sample, okay? Okay, and then they talk about mass. If I have a little bit of water, like a small little bottle of water like this, and I weigh it, it's going to have a smaller mass than when I weigh my cup of water. Okay? And they're going to be different. Is it the same solution? Is it the same substance? Yes. Okay? But they're going to have different masses because of the different containers that they're in. That is an extensive property. The same thing about volume. This is a lot smaller volume. This is only 59 milliliters, okay? Over here, I got like 30 ounces of water that if I were to fill it all the way to the top, it can hold, okay? Those are different numbers, same substance, different numbers, extensive property, okay? 2 different measurements. Now, volume we already talked about. Here's another example of the different volumes. Like here, this cup can only hold 8 ounces of milk. But this container, this pitcher, can hold up to 2 quarts. Is the same substance inside both containers still milk? Yes. But because they are in different containers, they will have different volumes. Is that okay? Does everybody see how all of those are measurable? Volume, mass, length, width, height, all of those are examples of stuff that we can measure, properties that we can measure, okay? And extensive doesn't really help in identifying the type of substance that you might be that you might have found or using, but intensive properties do help. Okay. Now, what is an intensive property? An intensive property is a property of matter that depends only on the type of matter in that sample and not the amount. So this, I like to say, is not measurable. Okay. And I'm going to give you a bunch of examples and you're going to tell me, can you measure it? Okay. And if you can't, it's intensive. Okay. So the first example they talk about here is electroconductivity. Okay. Now, if I were to put this and this with a live wire, well, this plastic is not going to really carry that electricity, right? I can put it in the electricity and touch the container and nothing's going to happen. But if I put my cell phone and then I touch it, I can get electrocuted, right? Because this cell phone has metal properties, okay? That is an intensive property, okay? Plastic doesn't have that ability, okay? I like to always think of intensive properties as an ability of some kind. Okay. You have a bunch of examples at the end of this paragraph: color, temperature, density, and solubility. Now let's go back to temperature. Why would temperature be a intensive property? Okay. So let's say I have my water, and instead of it being ice cold, well, it's room temperature, right? It's room temperature. I pour it into another container. Is the water still the same temperature in both containers if it's at room temperature? Yes, that is considered intensive. Okay, it doesn't change just because there's a little bit of water in the plastic and a lot of water in the Yeti. Color. If you look here at this copper wire and I were to just cut this little piece, will it have the same color? Yes. Is it the same substance? Yes. It's just in a smaller version. Solubility is the ability to dissolve. If I have salt can easily dissolve in water. Sugar can easily dissolve in water as well. Okay. Let's see. What other examples do they talk about? Oh, they talk about the copper wire. Uh, Even if I had a little piece, that little piece, if I cut it off and I put it in somewhere where with electricity will easily pass through it. If I put the whole thing, the whole wire, the whole roll, and I attach it to something electrical, it's gonna carry it. Okay. Here, let's see, Mr. David, what he has to say about it.
When you study chemistry, there's a lot of things that come up when you're making measurements, and we'll refer to it being an intensive or an extensive property or variable. And what we mean by these is we really mean it's a property that changes with amount, or it's a property that's more intensive, which doesn't change with amount. And right there is really what your definitions are. Any property that you can measure that as you change the amount of substance, but that property doesn't change with the amount, is called intensive. A really great example of this is temperature. It's one of our premier intensive variables, if you will. Great example, if you had a glass of water that's 25 degrees C and you pour half the water into another glass and ask yourself, now what's the temperature? Temperature is still 25 degrees because it's an intensive property. It absolutely does not matter about the amount that you have. It's intensive. Now, let's compare that to the mass of the water. If I have a glass of water, I know its mass is, say, 500 grams, and I pour half of it out. Now the mass is not 500 grams, it's 250 grams. That's because that's an extensive variable. Extensive properties vary with the amount, and we love to quantify amounts. We quantify in mass in grams, we quantify amount itself in moles of substance. We quantify length How long is something? How tall is something? Volume is a great example of an extensive property that actually brings in length 3 times: height, depth, and width. You multiply all 3 of them, you get yourself a volume, which is very extensive. You get more amount, you get a bigger volume. An interesting thing, though, about extensive properties, if you ratio one extensive property against another extensive property, you get an intensive property. A great example of this is density. Density is mass per unit volume. The mass is extensive. The more you have, the more mass you have. Volume is extensive. The more volume you have, the more the number goes up. If you ratio them, mass divided by volume, you get density, and that's intensive. The water example I gave earlier, when I pour it, doesn't matter when I split it. The density is still approximately 1 gram per milliliter. Even in the part I poured off, it's 1 gram per milliliter. So this is an important concept you will see over and over when you're answering problems numerically in a chemistry class. Is the answer an intensive or is it an extensive property? One last thing. Extensive properties by themselves tend not to reveal much about what the substance actually is. For example, let's say I have a substance and I tell you it's 500 grams. That really tells you nothing about the substance other than the amount I have. But if I tell you I have a substance that has a density of 1 gram per milliliter, it really limits you on your choices of what that could be. And so what we tend to do in the sciences and what we do in chemistry is we list intensive properties. And if you get a good listing of them, it truly identifies that substance as being a unique version of those intensive properties. Meaning, we like to characterize matter by listing intensive properties. And that's really what the importance of both of these things are, and you need to keep track of them.
There's a lot of examples, not just, the ones that we talked about. For example, if we're trying to find an unknown, one of the first things that we're going to try and identify is the density. We're going to see if we can calculate that in a certain way. And there are different ways to do density of substances. But another intensive property that always comes to mind is flammability. Okay, not everything can combust, can light on fire easily. Okay, gasoline we know can easily be lit on fire. We know also oil can be lit on fire. Now, that's an ability that not all substances have. That's an intensive property. Also, metals, when you're leaving them outside and they begin to rust, that is an intensive property. Okay. Luster, again, shiny. Not all elements are shiny. Intensive. Okay. That's part of color, you could call it. What else comes to mind? Can't think of anything else right now other than those. Ductility. Not everything can be made into wire. Okay. Ductility is definitely intensive off the top of my head. Okay. Any questions? All right. So that's the end of our lesson. An extensive property is a property that depends on how much matter is in the sample. Remember, if you can measure it, extensive. Mass and volume are examples of extensive properties. Length, width, height, also extensive properties. Intensive properties, now that's a giant list, okay? And we already started talking about some of those examples. But the definition is a property of matter that only depends on the type of matter in a sample and not the amount. Color, temperature, solubility, ductility, luster, combustion, the ability to rust, ductility, malleability, and what else? They talked in terms of density, boiling point, melting point. All of those will not change because of how much you have, okay? If water boils at 100 degrees Celsius, It doesn't matter if I have a little bit of water or a gallon. Both of them will heat when it reaches that temperature, or it'll freeze at 0 degrees Celsius, okay? Okay, those are just the examples off the top of my head. All right, so you got 4 more questions to do for this section. You are not to leave after you're done. You leave at the bell, which is at 12:10. You have 9 minutes to finish up this section, okay? Let me pause the recording.